Hi, today I'm going to build a bridge and we're going to see how much it can hold. The directions for this bridge is that it's to be no longer than 30 centimetres. We are allowed to have an overlap of 5 centimetres at either end to secure the bridge to between two tables. So space could allow, today I've actually secured my bridge between some recycled egg cartons. Let's take a look at the process. When we're thinking of STEM, it's a great integration of science, technology, engineering and maths. If we think about strong structures and the bridges that we see around us, have a think. What do they use? Do they have something in common? Draw yourself a plan. As you can see below, I've planned out my bridge with an overlap of 5 centimetres, and I've used triangles because they create a very strong structure. Again, thinking of the shapes, I started to glue together the base. For the base, I've used a combination of squares, which I've then joined together to make one long triangle. I created the measurements and found out that I could have 4 popstick squares long, creating one long triangle, which would be equal to just under 30 centimetres. From there, I've made sure that I can secure either end with an overlap. Squares were the way to go. I've used squares to create the base, again joining them with rectangles, and I used triangles to create the sides. How I envisaged this bridge is to ensure that something could cross over it, because essentially that's what a bridge is for. I pictured matchy cars or small little dinky cars that could go across it and we could test the weight. As you can see, I created the base and then joined together the sides. It was all measured out so that we would make sure it didn't go over the quota. And here we go. Here is our bridge. To join that base together, I inserted the pop sticks through one another to create that extra security so that they were, in a sense, pinned between each layer. I then decided to test it out. So let's see how it went. So to test it out, we're going to weigh 100 gram weights and see if they can hold our bridge. I've weighed out some water into a container and I'm going to put it there. So that is that first 100 grams. Let's see how much more it can hold. Our second 100 grams. And our third 100 grams. So at the moment, our bridge is holding 300 grams. How much do you think it could hold? Do you think you can make a bridge? I challenge you. Now I've completed my challenge, it's your turn. I can definitely say that I have created a strong structure. However, if this was put into real life size, would it be as strong? Would it be alright to use wooden materials, or would you consider using a stronger substance to create this? These are all the amazing questions and possibilities that are left open to us in the world of STEM. I hope you've enjoyed this.